Hello, from me and the others within this video, we are the Big Idea team. As part of the Big Idea project, our team has been tasked with exploring the permanently shadowed regions of the moon, or PSRs. As part of this mission mandate, our team has decided that our goal is going to be exploring these regions for sources of water and hydrogen for use on future missions. In order to achieve this end, we are going to be developing two components for the project, an impactor and a sensor array. The impactor is going to be sent on a collision course to the lunar surface to impact and create a dust cloud. From orbit, the sensor package is going to be scanning the resulting dust cloud and identifying sources of water and hydrogen. Both of these components are going to be explained shortly.
Our initial idea was drilling into the regolith after impact, then retrieving a sample. We would then weigh that sample, we'd heat it to remove the water, we would then re-weigh that sample to determine the water content of it. Our analysis plan changed after we determined the impactor wouldn't survive, and if it did manage to survive, it was very unlikely that our instruments would remain calibrated. Our new idea is to use the impactor to kick up a dust cloud and then analyze that cloud for its water content.
For the design of our impactor, we initially developed a simple rocket shape in which all of the internal components and electronics would be protected on impact. After we determined this design wouldn't be feasible, we created a new impactor with two primary objectives. One, reach the PSRs without any regard for survival on impact, and two, create as large a plume as possible for us to analyze. To accomplish this, we developed a teardrop-shaped structure with an internal mounting board in which all of the subsystems necessary for us to get to the lunar surface would go. These will include electronics, communications, battery, and potentially reaction wheels.
For the Big Idea project, my time was spent on the material aspect of our design. We decided to use stainless steel 301 for our base and aerogel for our insulation. Both of these materials met our requirements of low cost and low weight. Plus, both of these materials have been proven to work great in cryogenic temperatures. To measure our dust cloud from our impact, we decided to use UV spectrometry similar to L-Cross's method.
Our housing unit will be mounted to the Eclipse system using an adapter plate. In this housing unit, we will have an instrument box which will contain our 2.4 gigahertz 802.11n Wi-Fi transceiver module. This module we will use to communicate with our impactor as needed, as well as to send any data collected from our UV spectrometer to the Eclipse system. These components and others will be powered using lithium-ion batteries, which we found to be most suitable for our needs.